we are going to start lesson number 55. So, what is lesson number 55? As you can see on your screen, lesson number 55, as it is mentioned, it's Newton's law of gravitation. Newton gave us three laws of motion. That was first law, second law, and third law of motion. And this is its fourth law, but it's not for motion; it's for gravitation. What Newton told us, I want you guys to listen carefully. Inshallah, you will understand, and I will try to keep it as simple as much as I can.
How are
Newton
you, Mr.
told, fine, Alhamdulillah. So Newton, in his very important law of gravitation, told us that every object in this universe attracts every other object. Every object attracts every other object by a other object by a force. He named this force as a gravitational force. The first point is, in his law of gravitation, Newton told us that every object attracts every other object. What does it mean? It means that, like I am an object of the universe, I attract the walls, I attract the table, I attract the rack, I attract the laptop, and these things are also attracting me. So every object attracts every other object with a force. But what is the amount of force? That is really important. This amount of force, F, can be calculated in two steps. He said that this force is proportional to product of the masses. So he said that this force is proportional to proportional to product of their masses. What does it mean? Product of masses of the object. Mathematically, we can say that F is proportional to mass of the first object times mass of the second object. For example, if I'm talking about myself, this is Mr. Athar, and he is standing at some place and he attracts a table in front of him. He attracts a box placed near to him. So the force between me and table depends upon the mass of myself and mass of the table. So the product between me and table is 180, whereas the product of me and box, if it is 1 kilogram box, so the product is 90. So every force, there is a force between every object. The force between me and this table, me and the wall, me and the chair, also AC and me. So every object is attracting every other object, but this force depend upon the product of masses. If the product of me and table is more than me and box, so the force is dominant between me and table. So I should attach with the table. But why I'm not attracted by the table, or I am not fixed or just glued with the table? Because there is another object that we are talking, we are not just concerned, that the earth is another object of the universe. So if you talk about the mass of the earth, you have to memorize this mass of the earth later on. So mass of the earth is almost 5.98 into 10 to the power 24 kilogram, and this mass is huge as compared to the little objects like table, wall, house, building. So the product of me and earth is a huge, a lot more than me and wall, me and room, me and the cushion or the table or the laptop. So which have more product, which two objects have more product of masses, that will have more force. So Newton told us that every object is attracting. No question comes in your mind that if every object is attracting, then everything should be attached to each other. Like this rack should not be away from me, it should touch me, the table should touch me, the laptop should fix with me. So why it is not happening? Because the force between me and laptop, or force between me and this table, is a lot smaller than me and the earth. So the force between every object is there, but the more dominant force is who, which two objects have more masses. More the product of mass, more the force. He conclude this law in 3 points. First of all, he said that every object attracts every other object. Okay, everybody get confused. Oh no, every object attracts every other object. So it's very confusing. But then he told us the force between two objects is proportional to the mass's product. So more the product of the mass, more the force. And third point, he said that it is also inversely proportional to force is inversely proportional to distance. Force is inversely proportional proportional to square of distance between them, square of distance between them. So distance we use with d. So he said that f is inversely proportional to square of the distance. If these are the two objects, now listen carefully, the distance we will start with the center of the objects, from center to center. So this is M1, this is M2, this is D, from here to here. So force is having two important features. If we combine all of these things, he said that force is equal to gravitational force. He put G small here, but I'm not writing here. Is equal to G M1 M2 over d square. Now this equation is called law of gravitation. In this equation, we have 3 points. First of all, we have m1, m2, and you know that m1, m2 are masses of the object. The masses of the both object. D is the distance between the object. There is another thing that is called gravitational constant G. G is gravitational constant. And from where this gravitational constant come? Whenever you have two proportional things, the constant always comes. You know, in math you studied about it, and its value is 6.67 10 to the power negative 11 Newton meter square per kilogram square. Now keep it in your mind that this G is not small g. Don't get confused with small g and capital G. Small g is gravitational acceleration, and it is 9.8 meter per square second. This G is gravitational constant. Here are two values proportional. F is proportional to m1 time m2. F is inversely proportional to d square. So this is proportional. This is also proportional. So as rule of math, we have a constant here. So this constant, Newton told us that it is gravitational constant, and he also gave us this value. So now don't get confused. I'm telling you, G is gravitational acceleration and capital G is gravitational constant. Newton told us that every object in this universe attracts every other object with a force. This force is proportional to product of the masses and inversely proportional to the square of the distance. This thing can be summarized in one step, that this force is proportional to mass of the product. It means that more product of mass means more product of masses means more the force. If product of masses is more, force is more. And this distance thing, if more the distance, if more the distance, force is less. So if objects are closer, their force is more. When objects are farther, they are away from each other, force will be less. When we combine this, we got F is equal to G m1 m2 over r square. So this is our first, you can say, equation for the Newton's law of gravitation. But before I move further, I just want you guys to focus. If we double the masses
Yes, sir.
of the
Yeah.
object, yes, Ahmed. If we double the masses of the object, but don't change the distance, what will happen
Okay.
to the gravitational force? Let me write the equation. If you forget, equation of the gravitational force
Oh,
is
Mister, it will be equal. Am I right?
just
The
just
same.
look at the equation first.
Yeah.
G m1 m2 over d square. This is the equation. I am
Yeah.
saying that double the mass. M1 will change into 2
Into
times m1, and
yeah,
m2 will change into
two times
2
m2.
times m2. Now I need what will be the value of force, the change force. For example, it was 2 Newton initially. How much will it become now?
4.
Will it become 4 or 8?
8, 8. Sorry, 8, 8.
8. Why? Because
Yeah.
both the masses are doubled. When masses are doubled, it means 2m1 times 2m2, it will become 4 times m1 and m2. So the force will become
8.
4 times. So here you will write it will change to become
4.
4 times. How? I am just explaining this thing again, that this is F is equal to G m1 m2. I will change it to change force F prime, let's say, or F new is G
M
2m1
2m1 like 2m2
2m2 over d
over
square.
d to the power of 2. Yeah.
This is G 4m1 m2 over d square. Finally, I can say 4 into G m1 m2 over d square. What is G m1 m2? This is the force. If you see here, this is G m1 m2 over d square is the actual force. So you will say that the new force F prime is equal to 4 times the actual force. So the force is 4 time increase.
For
Okay. If we double the distance between the objects but do not change the masses, gravitational force will become. It will become. Wait, if this is 1 over 2, then it's 1 over 4. It will be less.
Yes, it will be less, but how much? Let me give you the
Uh,
option.
by
Will it
half.
will it become will it become half?
Okay.
Will it become quarter?
Okay.
Will it become 1 over 8 time? Will it become 1 over 16 time? Half mean 1 over 2. Half mean 1 over 2 time. Quarter mean 1 over 4 time. So what will be your answer?
So if it's already half, and then we double the distance, which is 2, it will be 1 over 4, which is half. So is it A?
Are you sure?
I think.
Look here. How will you do this? This D is changed. Everything is not changed. So you will write F is equal to GM1 M2 will remain as it is. D will
Yes.
change into 2D and there is a square upon it. So it will
Yes.
become Gm1 M2 over 4D square. So this can be new force is equal to 1 over 4 times Gm1 M2 over D square. So this is the force. Initially it was Gm1 M2 over D square. So you can say that new change force is equal to 1 over 4 times actual force.
If you have distance between the objects but do not change the masses, gravitational force will come. Miss, I think it will become 1 over 2.
It will quadruple.
It will quadruple, means 4 times, not 1 over 4. Can you please explain me what will happen?
Yes, mister. Because 1/2 squared equals 1 over 4.
So 1 over
So,
4 is in denominator, so this 4 will move up. Let me show you
yes.
here. Thank you so much. Thank you for your good answer. That's appreciated. So new force will be G m1 m2 over d over 2 square. So this will change G m1 m2 over d square over 4. No, you know that if it is written 5 divided by 1 over 2, what you do? You multiply it by 2 over 1 and your answer is 10. 5 divided by half is 10. Similarly, here it is the fraction mean division. So it means you will write gm1 m2 times 4 over d square. If you simplify this, gm1 m2 over d square, what is this thing? This is your actual force. So you will say that this is actual force times 4. So as you said, it will be quadrupled. So it will be 4 times or quadrupled. Your answer will be 4 times. Okay, I'm hopeful that you guys might understood a little bit, but you will get understanding it as the time passes. Now I am going to solve an example from your book. This example is about there are two students who are closer to each other and they are having a chit chat or talking to each other. During their discussion, we are supposed to find the force between them. So what is the force between them? Let us find it. If you are able to see, this is example number 5.9 of your book. Can you attract another person gravitationally? One person is 50 kilogram mass. So what you will write? First person m1 is 50 kilogram. It looks like uh, uh, it's the younger one 50 and m2 is 70 kilogram. Okay, now these are the two masses. They are sitting on a bench close to each other. Okay, when you sit on a bench close to each other, your maximum distance can be half a meter. So distance is not mentioned, but you will put is, because this is estimate question, so you will say that it is half a meter. Now you are supposed to find force. How will you do that? For that purpose you will use the equation F is equal to g m1. I need you to hold the calculators please. G m1 m2 over d square. G is 6.67 into 10 to the power 11. I am not writing the units because you may get confused. So m1 is 50 kilogram, m2 is 70 kilogram, and the distance between you guys is 0.5, and you will square it. Guys, here I would like to add a little bit. There is a mistake in the example we solved 5.9. The masses were given as m1 50 kg, m2 is 70 kg. Distance between two people sitting together is approximated to zero point 0.5 meter, and value of g we know that it is 6.67 10 to the power negative 11. Here I would like to add one more thing, that when you have this all, so F is equal to G M1 M2 over R square, or you can say F is equal to G M1 M2 over D square, because D and R is the same thing. We can write R or G. When we substitute the values, we get 9.34 into 10 to the power negative 7, and 9.34 when you round it, because your question is about the approximation, it is 10 to the power 1 into 10 to the power minus 7. So you can simply say 10 to the power minus 7 plus 1, that is 1 times 10 to the power negative 6 Newton. So I would like you guys to correct it. Thank you so much. Let us move to the next example. This is example number 510 from your book, and this example is about the spacecraft. This is 5.10, sorry. So this is about the spacecraft. So spacecraft is 2 radii from the Earth's center. So radius of the Earth is given, mass of the Earth is given, mass of the spacecraft is given. Let me write in special way m1 mass of the spacecraft, or I can write ms, that is 2000 kilogram. Please hold your calculators with you. Mass of the earth, you know that it is given 5.98, and I told you you have to memorize it. I will not give you this value. So radius of the earth is given. So distance between center of the earth to center of this planet is 2e. So you can say that it is 2 times re, and re is given 6380 kilometer. So this answer is becoming 12,760 kilometer, but we knew it to convert kilometer into meter, so it will become 1000. So your total answer will become 1,200,000. Sorry, if I am not wrong, it's 1 million. Can you check your answer, please? 12,760.
This is 12 million.
Yeah, 12,760,000 meters.
Yes.
So I multiply by 1,000 after multiplying by 2. Now this is your DMEMS. So substitute the values. We have the rule. Here we have the rule. F is equal to G M1 M2 over you can say R square or you can say D square. Both are okay. So F is equal to, as you know, G is 6.67 times 10 to the power negative 11 Newton meter square per kilogram square. M1 is mass of the satellite, that is 2000, and M2 is the mass of the earth, that is around 6 into 10 to the power 24 kilogram, over the distance is 2RE. So you can directly write here this 2 times 6,380 times 1,000 square, or what we round it here, uh, the answer 12,760,000. So let me try it here. What I wrote, I got 6.67 times 10 to the power negative 11 times 2000 times 5.98 times 10 to the power 24 over parenthesis, it's 2 times 1000 times 6,380 squared. So what I got is, it is 4,800. This is 4,899 Newton, and we can round it to F is equal to 4.9 thousand or kilonewton. That can be approximated to 5,000 kilonewton. So this is a very simple scenario that we can simply search. So we found that when radius is doubled, so the force changes to 4,900 newtons or 4.9 kilonewtons.
The radius,
Okay.
gravity as with graph two is the Earth. Yes, it's two times the radius of Earth.
If you guys remember, I told you whenever we are going to find force of gravity between two objects, we have to take the distance from the center of the first object to the center of the second object. So here,
Yes,
if you are watching at the figure, the center of the earth is this point, and center of
yes.
the this. So total distance from this to this, from here to here, it is equal to 2 earth radii plus 1 earth radii. So it becomes 3 earth radii. So total
Oh,
distance is equal to
okay.
3RE. So here,
Oh,
first thing, 2RE is above the surface and 1 is the radius. So total becomes 3RE. So distance is the first thing that is known to us. This is equal to 3 times radius of the earth. If you guys
yes.
don't remember radius of the earth, last week we did a question related to this. So next time, please, you have to memorize this. Radius of the earth is 3 times radius of the earth is 6,380
Eight.
kilometer. So this is the radius of the earth, 6,380 kilometers. Okay, this is the distance, the first thing. Second thing is given to earth, that the spacecraft mass of the spacecraft, let me write m1, or I can just say ms, is equal to 1,850
1,850 kilogram.
kilometer, and its unit is okay with me. But what is
It's a
second object?
kilogram.
Yes, what is second object?
The
Thank you.
Earth.
Earth. So do you remember the mass of the
Yes,
earth?
6 times 10 power 24
Very
or
good.
5.98.
Exactly. Yes,
5.98.
exactly. It is 5.98. But when you talk about 6, it's okay. 10 to the power 24 kilogram. Okay, now one thing is more important here. Value of G, I told you, you have to memorize it. It is 6.67. 10 to the power. I did a mistake last time. I wrote it positive 11. It is negative 11. Sorry for my mistake. Newton
So
meter
which G?
square. Yes, this is G, gravitational constant. This is not
Is it?
small
It's
g.
9.
Okay, now this is the data. By using this data, we can find the force between satellite and the Earth. For that purpose, let me start with the formula. The formula for the force of gravity, F is equal to G, M1 is the mass of the satellite, M2 is the mass of the Earth over
D
distance
square.
between their centers square. Now just you have to substitute the values, but before you go for substitution of the values, keep it in your mind that masses should be in kilogram, G should be in Newton meter per square second, Newton meter square per kilogram second, and the distance should be in meters. Here distance is in kilometers. So when we are going to convert kilometer into meter, it is 10 to the power 3 kilometers. 10 to the power 3 meter is 1 kilometer. So what can I do? At the same point, I just can write it as 3 times 6.38. So this decimal move from here to here, it is 10 to the power 3. And kilometer is also 10 to the power 3. So can I write 6.38 into 10 to the power 6 meters? What I did, I wrote 10 to the power 3 by moving the decimal from here to here, and kilometer is 10 to the power 3, so it becomes 10 to the power 6. If you are getting confusion, you can just write it as 3 times. Now you can see 3 times 6380, and kilometer is 1000, so put 3 zeros here. So this is the decimal. When you move it from here to here, how many numbers it will move?
6.
3 and 3, 6. So it is the same thing in meters. Okay, now we have the data. Let me write the data, and please, I need your help to solve it. So F is equal to G is 6.67, 10 to the power negative 11 times MS is mass of satellite 1850 kilogram, mass of the earth 5.98, 10 to the power 24 kilogram, divided by the distance we just wrote is 3 times 6.38 times 10 to the power 6, and there is a square on it, 2014 Newton.
14.2.
Okay, anyone else who did it?
Mister, I got
Okay. This can be written 2.01 kilonewton. Two objects attract each other with a force. So first thing is given to us is the force. So I am just going to write the given data. I have been given by the force, that is 2.5 into 10 to the power negative 10 Newton. Now they are saying that uh, they are 0.25 meter apart. So distance is also given in meters. So no need to change the force, no need to change the unit. So this is very good thing in this question, that nothing to change. This is very important sentence. The total mass is 4 kilogram. Okay, M1 plus M2 is 4.00 kilogram. Now what is to find?
Individual masses.
You have to find M1, you have to find M2. F is equal to G times M1,
Plus M.
M2, M1, M2 over D square.
Okay.
Value of G is 6.67, 10 to the power
10
negative 11.
negative
Okay,
11.
let me write it that you will not confuse. So value of G is 6.67, 10 to the power negative 11. One equation is the formula itself, and the second equation is the given data, that is m1 plus m2. We can rearrange this one and simplify it to solve it. How? Just get one mass isolated. For example, I put one mass like m1. I separate it here. What will be value of m1? Very good. 4 minus m2. When I
4
will
minus
substitute
M2.
in the formula, so what will happen? I will get the answer of m2. So this m2 I will substitute in this equation. I will get the answer for m1. Let us
Oh,
try.
okay.
Okay.
First one is start with f is equal to, sorry, f is given to us. So let me write with f, that is 2.5 times 10 to the power negative 10 equals to, G is 6.67
7 times 10 power
times
negative 11.
negative 11. M1 is how much?
4
4
minus M2
minus M2, and
times
M2 is
M2.
M2.
4
Okay.
minus M2.
Divided by the distance is 0.25 squared. The first step is this 0.25 is divided here, on the other side it will be multiplied. Okay, and 6.67 is multiplied here with m1 m2,
Yes.
sorry, so it will be
Divided.
divided.
Yeah.
Okay, now what will be the new
Divide.
equation formed here? It will be 2.5 times 10 to the power negative 1,
10
sorry, negative 10
times
times 0.25
0.25 squared
squared, thank you, divided
over
by
G, which is 6.67.
6.67 10 to the power negative 11
11
equal to
equal
4
4m2
m2
minus m2 squared.
minus m2 square. Very good. So this is going to be a quadratic equation now, but please, I need you to give me the answer for left hand side. What will be answer for left hand side?
Okay, one second.
Yeah, everybody please try to solve this part, left hand side, and give me the answer. Why you guys take too much time? 2.5 times.
Mister, I found the
You
answer
found the answer
0.23.
0.23. Okay, let me check.
Oh no, wait, I think I forgot. Oh no, I didn't forget anything.
0.23.
0.23.
Is everybody getting the same answer? I think it might be correct. Let me check. 0.23 is equal to
Yes, mister,
4
I get same answer.
minus m2 square. Okay, I am writing everything on the right side. So this minus m2 will become m2 square
Mister, but I get
minus
0.023.
0.023. There is another 10, because 10 to the power negative 1, when go up it will become 10. So 0.23 is the perfect answer in my opinion. Just check it out. You will get
Okay.
your answer. So 0.23. No, everybody please, I need your attention. If I put m2 as x, what it will look like? It will be a quadratic equation. Look here. Just for your understanding, I'm writing it. It will look like as it will be as x square minus 4x plus 0.23. So what is this shape? This shape look like
Quadratic.
ax square plus bx
Let's see.
plus c. So this is a quadratic equation. Now you can use mode 5.3 on your calculators. Go to mode 5.3
1
and
minus
write
4
I
a
found it, Mister.
1,
2
b
3.
minus 4 and c 0.23. So what is your answer? Yes,
I found
please.
it, Mister.
Two answers we have, Mister.
Yes, give me.
Yes,
One is positive
20,
and one is also
20.
positive. Two
Okay,
answers.
just tell me both.
Yes.
First one is
First one is
uh,
3.94.
3.94,
3.94 and second one is
0.0
negative.
0.05.
0.06.
Which one is negative?
No. Both are positive.
Both are positive.
You were saying one is negative. What do you substitute? A is 1, B is
Mister, I
negative
think the
4.
problem
B
is
is
in
negative
C. C is
4.
wrong. I don't think C is 0.23. We made something wrong in calculating C.
Are you sure?
Yes, I think this is the only way to have both answers positive.
No, Mister, because if you add the two masses, you will have 4.
That is something else. This is not the two masses. We are finding M2 only.
So
But
we solve
please,
C again. We solve for C again.
okay, see again. Multiply 2.5 times 0.25 square divided by 6.67 goes up. I think it is 0.23. You can
Yeah.
check it out. It is correct. 0.23.
Mister, how many powers
Mister,
of Mister, how many powers of 10 we have at the end? -1, right?
No, one positive.
1?
Yes, because this negative 10, 10 to the power negative
Oh,
11 will
okay,
go
okay.
up. It will be positive.
Will go
So
up to 8.
0.23 is perfect answer.
So we have two positive answers.
No problem for that. No problem. Whatever you will put, because they did not mention M1 is heavy or M2 is heavy. So we can use both of them and we will get our answer same. So the second answer is M2 is 0.06.
Yes, or 0.58.
0.058.
It's
05.
Okay,
0.8.
0.06. It's okay. Okay, now we found two answers for M2, but the question was that find M1 and M2. Now, when M2, and you will use this equation, M1 is equal to 4 minus M2. So now, let me make two sections, but both will give the same answers. When M2 is 3.94, M1 will be 4 minus
0.06.
3.94. It will
0.06.
become M1 is 0.06
06.
kg. So your answer is M1 is this and M2 is how much? M2 is 3.94 kg. Or the other way is
The opposite.
M1 is equal to 4 minus 0.06. Same thing happens here. So M1 will be
3.94.
3.94 kg and
Oh,
M2
okay,
was
okay.
0.06.
0.0. So because they did not mention us that which
Yes,
one
yes.
is heavy and which one is lighter, so we can give the
Both answers are accepted.
two possibilities. If M1 is 0.06, so M2 is 3.94, but the addition is 4. But if we consider M1 as heavier, so M2 is 0.06. But your answer is correct. No one can say that your answer is wrong. So this is how we can do our question. So please look at the question. I will try to show you the full question here. This is the problem. In this problem we were given uh, by a force, and in this force we have the distance, the collective mass is given, mass is given, separate mass to find. First of all, I move one mass to the other side, I make an equation, just use that equation in the for force formula. I got a quadratic equation. For solving the quadratic equation, I know you guys are very good in mathematics, but still I am going to write use mode 5. Use mode 5, then 3, and put a is equal to 1 because the coefficient of M2 is a, which is equal to 1. B is equal to negative 4. C is equal to 0.23. Put A is equal to 1, B is equal to negative 4, C is equal to 0.23. when you will do this, you will get the answer of m2. So this m2 you will substitute one by one in the first equation that we derive here, or if you want to use this one, it is the same thing. So you will find the both masses. So this was all about our discussion.